In this question, we have a student who throws a tennis ball with a mass of 57 grams straight up in the air and then hits it horizontally with a force of 420 newtons as it comes to a rest at the top of its motion. So we're going to determine the speed of the ball after the collision if the collision lasts for 4.5 milliseconds. And then we're going to go ahead and also find what happens if Brad has a better follow through. And the time of the impact was 5.3 seconds. We're going to look at how much more speed the ball would have. So it's just a difference in velocity there. So what do we know? Let's just note that we know the mass. So that's 57 grams. However, I want that in kilograms, 0.057 kilograms. The force is okay as it is, 420 newtons. And time, we don't want in milliseconds. We have to convert that to seconds. 4.5 times 10 to the negative 3 seconds. We also know that at the top of its travels, when the ball reaches a max height, its initial velocity is 0. So we're taking a look at the kind of system here where the ball rests at the top of its arc and then it's hit. So v1 is going to be equal to 0. v2 is what we are going to solve for. So we know impulse, or J, has two equations, and it is f t and m delta v. So this is important because we're actually going to use this part of our impulse equation. Set these equal to each other, and then we can solve for v2. So we know ft and m. We know that v1 is equal to 0. So if I take this equation and I just expand it a little bit, so I have f t m v2 minus v1. Well, v1 is equal to 0. So this part is going to disappear. That goes right to 0. And I can actually just rearrange my equation, and I'm left with v2 is equal to f t over m. This leaves me with f, 420 newtons, t, 4.5 times 10 to the negative 3 seconds, and m, 0.057 kilograms. So in this particular example, the velocity is going to be 33 meters per second. We can repeat this again with a different time, with time equal to, the question says 5.3 milliseconds, so that's 5.3 times 10 to the negative 3 seconds. We're going to repeat this entire procedure just with a different time value, and then you end up with a velocity of 39 meters per second. So how much more? So we're just going to look at the change in velocity, or the final velocity of the first attempt versus the final velocity of the second attempt. So the velocity difference between the two is simply 39 minus 33. So it would be 6 meters per second faster on his second or better attempt.